Hi guys, Miss Malik here. We're looking at exercise 5F from your essential textbook, and this is looking at the change of base and solutions. So let's simplify the following. We've got log E27 over log E3. So what we can do is we can say log 327 over log 33. We end up with log 327 because log 33 equals 1. So log E27 divided by 1 equals log 327. And we get 3 because 3 to the power of 3 is 27. Log 2, 1024 over log 2, 4. Let's make that log 4. So we get log 4, 1024 over log 4, 4. So log 4, 4 becomes 1. And therefore log 4, 1024 divided by 1 gives us log 4, 1024. That just equals 4 to the power of 5 equals 1024. So our result is 5. What about this one here? Log 4, 81 over log 4, 3 plus log 4, 256. Let's make it log 3, 81 because we want to get rid of the divided by log 4, 3. So log 3, 81 divided by log 3, 3 will give us just log 3, 81 because log 3, 3 is 1 plus log 4, 256. We still don't have the same base for those ones. But we know that 3 to the power of 4 is 81 and 4 to the power of 4 is 256. So 4 plus 4 equals 8. So log xy is like saying x to the power of what equals y. So when we have log 327, it's like saying 3 to the power of what equals 27. The next thing we will do is evaluate the following correct to 4 significant figures by using change of base. So log 210. Let's have a look at that. Let's make it log E10 divided by log E2. So that's approximately 3.322. My calculator showed me that. Now let's do log half, 6. So let's make it log E6 and let's divide that by log E half. Notice that I just take the base of the original log, so in the first one it's log 2, so 2, and I put that as in the denominator. So log E6 divided by log E half, that gives me approximately negative 2.585 as shown on my calculator. Note the approximate sign, not equals sign. Equals means exactly. Log 257. Let's make that log 1057 over log 102. That gives me approximately 5.8329. You could just evaluate these directly using your CAS, but the question asks us to change the base, so that's what we need to do. Make sure you know how to do it, but it is a bit of a cumbersome way of doing it. Let's look at this one. If log 26 equals k log 23 plus 1, we want to find the value of k. So log 26 equals k log 23 plus 1. We end up with log 2, 3 to the power of k. Remember that when you've got something on the left of the log, we can just put that to the power. Plus log 2, 2. Notice how I've put them in the same log. So 1 is just log 3, 3 or log 2, 2 or log EE. There we go, it's log 2, 2, so I have the same base. So log 2, 3k times 2. Remember that when you add them, you actually multiply. So I get 6 equals 3 to the power of k times 2. 3 equals 3 to the power of k. And 3 to the power of 1 equals 3 to the power of k. So k must just equal 1. Notice at this stage over here, where I have log 2, 6 equals log 2, 3 to the k times 2, my logs are the same, log 2, 6 and log 2, 3k, 3 to the k times 2. So that's where I can get rid of the logs and just solve for k by 6 equals 3 to the k times 2. So once you've got your log base the same, you can quite easily solve for the pronumeral, as you saw there. Let's solve for x if 2 to the power of x equals 11. We want to express the answer to two decimal places. So 2 to the x equals 11. That's like saying log 10 of 2 to the x equals log 10, 11. So x log 10, 2 equals log 10, 11. I can then just say x equals log 10, 11 over log 10, 2. And on my calculator, I approximate x to 3.46. Let's solve for x if 3 to the power of 2x minus 1 equals 28. We want the answer correct to two decimal places. Watch out for that. They'll tell you sometimes how many decimal places. Make sure you do the right number. 3 to the power of 2x minus 1 equals 28. So let's log that 10. Log 10, 3 to the power of 2x minus 1 equals log 10, 28. Because the bases are the same there, I can say 2x minus 1 log 10, 3. So I've just gotten rid of the index there by putting it in front of the log 10, 3. So log 10, 3 equals log 10, 28. So now I can solve for 2x minus 1 because I can divide log 10, 28 by log 10, 3. Let's put the 1 over the other side and divide everything by 2. Approximately x equals 2.017. Now here I've done this badly because I put it to 3 decimal places. We actually only want 2. That's what the question tells us. So it would actually be x is approximately 2.012. Oh, sorry, x is approximately 2.02. Again, these are things that you could do directly on CAS, but in the non-CAS section, they may want you to show like this, where you wouldn't have an approximation. They just want to see how you go about it and how you can get x on its own. And that's the end of that exercise.